This is I've gone through some of that, and it's changed. The way the init works is different everywhere. So what that means is when you do this, then you'd have to pass the allocator everywhere, and we there are some usages of that in the code, maybe in the threads or something. But anyway, I didn't update everything, so some of this is still the old style. We also got the new style of generics in here. I don't know how that's like the best way to kind of make this readable. Maybe something like that or whatever, or if you should actually go tightly. I haven't decided yet. I guess that's the downside of this kind of syntax. So, but before we can go in here, I should probably convert the unit tests. So we have all these the test suite, right? And that one is changed, but we don't have this. So I'm just going to go ahead and copy the entire set of unit tests. So we're going to call that unit 7 because it's going to be different again. So what I want to do now is that I'm going to, let's say here, have the, there's this test for the standard library, and we're going to change that one. We're going to actually take a copy of that one. So let's see if I can do that. There's a copy, and we call that lib7. And so now we enable generics, but we're also going to set like the stdlib is going to be this lib7. And now I'm just going to check that this works. So nice linking, running the tests. Hopefully this is, oh no. Map could not be found. Yeah, right. We removed map. So that's correct. Good. Let's fix that. So in this, I wanted to do this so that I get like this wouldn't be like that much of a diff here. So let's see here. So replacing files, we can remove these things. Okay, replace all in, yes, 72. And then we're going to go for replacing files. Let's get this one. And we go like that. Oh, replace all. And let's see here. So we have this. Wait. Where is this one? This one. This is the original one. So okay, that one shouldn't change. But we have the other one. So again, maybe I didn't test the right one. So let's see here. Did I test the right one? We want to test, yeah, still lib, but we want to run the unit test on what? On unit, but we do unit 7, right? So now it's actually testing the right thing. Okay. Oh, I only, like, did I accidentally change, you know, no, I just forgot about it. Okay. So unit 7, replacing files, and we can do this one again. Right. Replace all. Okay. And it's so confusing because I get this map here, which is not the one, like the not the same thing that I was testing for. So now let's see here. What? What the heck? Okay. So didn't I want to replace in files? Did I just do something else? Like, what the heck? Right, okay, I replaced them all. Generic module looks like the one elements, and but you applied supply two. Okay, let's have a look at this. Okay, so we have the map one, and that one goes away. So we don't do that that particular test with the what test map. Right, test map test map up, and then it does the same thing I think with the test map, test hash map, test map. We don't use that one. Right. Well, now let's see what changes it would do to the ring buffer. So the ring buffer in units in stdlib, the new one. Yeah, it looks like it just has the type. Instead of this, it's just like, let's have, this. A ring buffer is just this data. And then we have the formatter. Okay, so now we get to format. That makes sense. But it should have dynamic. And it should implement the printable. And it should also import std ion or recurse. Oh wait, it should be recursive. Bam. Okay, now I get like a bunch of errors here. That sucks. But we'll see, because this is kind of interesting, because this will kind of give us some idea of how it should look. So in our case, we have now again, we're doing it differently. So okay, new width capacity. This is one that changed with this. Its naming is weird. This new width capacity, maybe it shouldn't be like that. It could be just like width capacity. Okay, but now for now I'm testing that. Okay, what else? We go into here. So the new one with the encoding test is, instead of this temp decode, we just do t decode. And yeah, that's just the change of that. And we have the same encode. We just do a t encode because that's like the t prefix, and I'm just optimizing for that I'm assuming now that we're doing most of the things on the temp allocator anyway. Okay, we get the enum map, and it's a string format, and it's missing the allocator, and we don't want this anyway. So these are going away because they're not very useful. So we just keep this like this to format. Okay. Then we have this one. So the buffer length, the buff cannot be found. Okay. The self buff, of course. So self buff length. There, the IDE crashed a little. In a sad way. Okay, so self buff there again, and self buff. Like I'm thinking that I have, C++ or something with a self implicit, but that's not the case. Okay, so we have to format here. Print f what? Print f. That's the one. I don't want anything else here. All right, the ring buffer again. The same problem everywhere. Where I think I copy pasted this one. And right. Now we get something. Okay, temp init with array, right? So that was that one goes into this. Let's see if we have something. Okay, this is interesting. So this is removed here, because we don't never need this defer this test free here, because this will be on the temp allocator by default. So this might be a bit confusing, but I just moved everything that's not like this. It should be it's on the temp allocator. So by default, I put everything in the temp allocator, which means that people will just use a temp allocator, which is, you know, it's good and bad. But I think that's like the normal usage. Oh, here we got like a normal one, right? We have a new init with array, so we just get that, and then instead we put a mem in here. Oh wait, is this one used init with array? Shouldn't that, shouldn't that have leaked? Is that even, everything is tested. This is weird. I think that would be a leak here, right? It should be a leak, so it should be a defer foo free. In this case, it's fine because the T in it, right? But the other one, it's weird that we didn't catch that one. Okay, let's go up here. We have new. Okay, let's run these tests. And meanwhile, hi, Danny. Yeah. Okay, we are going to go for this one. Let's see, there are some few left here, but I wanted to. Hopefully, we can get to the tests, to the unit tests of these, and kind of see. Right, here's one. So here's a new format, and that one goes into mem format like this, right? So mem format, so mem. There's just format, and I think this was something I was annoyed by before, and now it's kind of now it's getting better. So here's another one. It's like this new int here. This is not good. So that's something I want to fix, but I'm going to do like that later. So we're going to go into this code and just do a lot of hack and slash style changes. And so people were asking me like, oh, here's interesting. So I don't need to do this in it. I can just do that like that because it will be the temp init by default. But okay, so this is how it's going to look, right? So we get all of these, they kind of go into tinit, which is shorter, and I think, like, to me it feels lighter, much nicer to have that and then temp init. But with the new init together with then it had to be like a temp init, or it would feel really weird. So we can have T init and a new init. That would not make a lot of sense. All right, so I think that kind of took care of a lot of those, but let's see where we have more problems. Right, we have a lot of those, so let's go into new parse. So again, we have like new parse, mem parse. So that's the whole thing going into, you still you just do parse, right? And then it happens to be, it's you have to give it the memory in the beginning. So because you're allocating. So this was what we had like this long discussion about on the Discord, because I wanted, if you just had this like parse, there would be no way to kind of indicate that this was going to allocate memory. So that's really hard. Now we see that like there is some memory going into this whole thing, and obviously then you have to release that memory, right? And it's kind of probably easier to think of like, okay, maybe I can make an arena allocator or something to handle this, right? If I want to just keep it for a short while. But now we have the temp allocator, which will basically do this for us. So unlike other languages, this is kind of very convenient to have this temp allocator all the time. And we can, if you have the temp allocator, then you can have like so pool at the top here, and then this is going to collect everything for us. So let's continue through this. I'm talking fairly quickly now. I'm noticing. I hope you follow along. Right, so there's a lot of these new parts here. Maybe I should just, okay, I'm like halfway through, so I'm just going to do a search and replace. So we have, what's it called? Parse, new parse. And that one is going to go into, it's going to parenthesis, right? And we're going to change that with a parse mem comma. So we're going to replace these 8 cases with that. So now we're going to see where our other issues are. Right, we still have a bunch of them. So we go to, we have a new format here. Let's see if we have a lot of these new format or is just a few of them. Okay, so we might have a lot of them. So new format. So if you have this, then again, we're going to go to, format mem to replace all of those. And you kind of see, so all these old new format that was kind of, is that the format is new, is it an allocation that goes away? So that feels nice to me. Even though this is kind of Zig-like. Okay, so expected one more argument after this one. Yeah, so here's interesting. So if you do free on memory, you need to have, indicate what kind of memory you did. But you can also do these just free, right? So this is kind of fine in this case. So we're gonna replace all of these strmem free, these frees with this just defer free stir. So that's gonna be like the same thing. Should be fine. Oh, there was just one of them? No, there's. Okay, sorry, that was just the right one. So we have 10 of them. So let's replace all of those. Okay. So I understand that this will kind of be like kind of an Armageddon for anything because of these the prevalence of these init things, right? So here we go. Like here is as a query builder. We want to have something, we use mem to kind of create that one, and then it will be free later on, right? And here's another one. We do, okay, query free. Oh, it's a string one, so we can, just free that one. It's not very useful actually, this one string free. Okay, and then we continue along. Here we go with the URL string again. We just want to free that one. Oh, we have the parsed, but that one is handled correctly. Right. I'll go to that one. Expected one more argument. Okay, so we have another one. Really, that was a really dangerous function actually. The free one, because it's kind of, you kind of think it's going to do the right thing, but it actually requires that extra allocator if you allocate it from something else. So I guess that's good. It's gone. So there's another one. We have like more of these new formats again. We're going to go for format, and then we have provide the memory, because that's the way we indicate that that one is allocating, right? And we go for another one. Here's a split. So split before was going to go for, again, the memory, go for the heap memory, but it didn't tell you. So again, there's another one, and we can actually do the split by like doing the t-split instead. Now we don't need to do anything about it, but okay, we have some freeing of this, so that will just create bad things. So there's a split buffer. That one doesn't free anything. And then we have this other one. Okay. Split buffer. Again, we have some split buffer and then a normal split. An index of, in reverse index of. And that was pretty much it from those. Okay, so for now, let's just go back and kind of see what's left. Oh, still a lot of them. So there's a dstring new, right? And new must have a allocator. That's just the way it is. And so all of these now have an allocator. So the question is like whether new is the correct name for this function, because it takes the string, and there's another one with like new with capacity. So it's like what's a new one? Is that one with no memory, no allocations, is like an empty string, or the one that actually takes a string and creates something? I don't know. I think dstring from string or something like that would be more natural. So dstring from string, and then we have this thing. Okay, so new join. So this is why I'm happy about this change, because new join is like a horrible name. We have temp new, so I think that was like just has to be t new, right? So it could be temp too, but that's just like somewhat confusing, I think. So t new, and then we just go down. Oh, here we have another new, and then we need a mem, right? And another one. Maybe I should just do this. Okay, so dstring. It's not the last one. Yeah, of course. Like you remember that you can do search and replace when you get to the last one. Right. I'm like looking for this scroll bar here to get smaller, and it's like slightly smaller now. Soon it will actually do the test. Meanwhile, let me look at if anyone has any comment. Okay, right. So, okay. Every time you use, it's also surprised me how effective it is at detecting errors. I went back to writing Muslim Sleep after trying various better C languages, mainly Zig, and I'm saying that I want PC with the bad parts replaced with better parts. Did some OpenGL with C3 today and was really happy with the results. Cool. Thank you. Don't mem instead of mem on line 154. Well, some 154. I guess we'll grab that one later on. 154. Right. Yeah, men. Yeah. I do kendo. So the men is the head gear, the head things. You shout out men when you hit that target. So that was maybe I've done too much kendo lately. Okay. Anyway, so new concat. So we got the concat. It's also like getting a better name. So the naming is. That's what probably pissed me off about doing this the most. It's it's kind of painful, right? Copy has to have a memory. Yes. Now we go for the copy always requiring the memory, right? And so mem cannot be found. Okay, that's the mend thing. Okay, so here is another one. So I'm kind of I what I want to get to is kind of the part where you can see a bit more about how it feels. Like I want to have the feel of this. Okay, apparently that was on the test check. That's oh wait test check. Yeah, the test check it would be different, like right. Okay, so new format again. We go like okay, we have that. Yes, let's just run it with memory, and the temp init. So here's a list, right? And now we get the new syntax here too, right? Oops. And so we can get do the t in it here, and then that just works. Okay, and two T string, right? So I remove that function. So this will not work. But there's absolutely no reason why you would do that since you can print the list anyway. So let's just do that. And it's kind of good. That's a good thing, not having this like two string, because nothing in here is actually wants you to. You don't even need this, right? Why? There is no need to do that because you have it's going to be temporary allocated anyway. So that's kind of nice actually. That kind of gives you a, like, if you don't need to store it in memory, okay, you're not gonna get it. You're gonna get hit in the temp. Well, I kind of like that. So you kind of can go through and kind of just delete things here, you know, because let me just, oh, here's, I don't care about, tabs versus spaces, but I do want to try to keep it consistent. So toggle case, where's the change here? I'm just using the everything to kind of convert this to tabs. Yes, thank you. Oh wait, was like one space in. No. Okay, now it works. Now it should be. Oh no, this not this one. All right. It just should be consistent, right? So hopefully these are consistent now. Maybe no. Someone uses 5-character indent. So and no, everything is indented by one step. What's that? What's that? What? Okay. Sad face. Okay, that one is like here. Now there's like yeah, that looks good. These are still like have the wrong indentation. Oh, sadly. Okay. Yeah. That's not so nice. This is like not crucial to fix this, but yeah. 5 characters. This is why people hate spaces, I guess, because now if I have some other indentation, then everyone has to change their stuff. I didn't think about that. I didn't think that anyone had 5-character indentation, but that's the way it is. So 5 space indentation. Everything. Maybe I could have broken this. I don't know. I don't want to blame anyone. I mean it's fine. I mean people are contributing to this. This is my task to kind of make it look good. Make it look consistent at least. So I don't care what the code. Some of the best test code looks like crap. But okay. Okay, I don't want to continue doing that. Someone else can maybe do that later. Let's just continue into our investigation. So again, here is a temp init. We just delete that. Okay, and here's a new init. Oh, here's the path. This is my fault. I wrote the whole thing, and it's very bad. So it was actually trying different things, and this was mostly like, I think I was like looking at Python had their path abstraction, and what might seem like a good idea in Python is definitely not a good idea in C3. But I knew you have to, like all these things that I'm removing are things that they had to be explored. That's just the way it is. You have to explore these things, and then you are greatly embarrassed by the crappy stuff you did, but you also had to do it because otherwise you wouldn't know how bad it sucked. It I actually learned about this, doing row editing, like in multiple rows. I started using that for actually fairly recently. I mean, just a few years ago. And I was like, why didn't I think of this before? Why didn't I think of learning this before? This one is so huge. These are like the test cases are for this one. It's pretty solid. It's a pity we won't keep it from that perspective. No, we'll keep the tests, but they'll have to be different. Okay, maybe someone is writing something, so I'm just gonna quick look. Okay, C3 is so okay. Wrote mem instead. So the Danish rule has been going on for. Okay, okay. So apparently it's very important that C3 switch. Okay. Anyway, so mem. We're here, and then we're gonna continue. Oh, this one. I think that one changed names. So okay, let me just run these and see how far we get. Okay. So we get to new windows. So okay, I changed that one. So it's like 4 windows for POSIX. So path for POSIX. Yeah. And so we'll have to have the mem thing, but this will just not be a thing. It's not super useful to just have this abstraction just in order to have being able to do these particular things for, like, okay, you are on Windows, so you want to do, but you want to calculate some paths for POSIX, so they have to behave differently. Yes, it's important, but it doesn't need to be this abstraction. You can go through some hoops because, like, I did the code for the test runner, and it was annoying. I was like, what the heck? What did I do? And that's the problem when you write on something, and you kind of write from what you assume will be needed. It's never anything good. Oh, this looks like a gazillion. Why didn't I? Okay, let's just do this. Okay, we have a lot of these. So new Windows. If I see so new Windows something, then we can just swap that for Windows mem, right? We can do that. That's 40 of them. Okay, so new POSIX. Okay, new POSIX. POSIX. New POSIX. Okay, and we change that one to for POSIX. Replace all. And now finally we need to have the new. So if you have some new and we have some character. Oh, there is no new. So we are all done with that. Okay. Now let's see if we get fewer or like if more compiled. Okay, so we have some for. Okay, what's this? Path for Windows. You can't cast string. Okay, I forgot about it. Damn it. Some of them didn't have this. Right, that was probably just those that I did manually. Right. Don't do things manually when you can do search and replace. Okay, we're almost done. So we just have a few stragglers here. Right, that was those two. Okay, so new absolute. Okay, so new absolute, of course, we're going to change that one. So new absolute that one's going to change into absolute mem. It's just three of them. Okay, there's just three of them. All right. Okay. Still, I think there's like still this horrible and annoying amount of things, but let's go here first. Okay, we have this path temp conv, so it's that one, yeah. So just get t. That's it. Now we go here, and we have in printf we have all these new formats, so we can do all the new format and change those to format mem, comma, right? So that's 20 of them. So now we see kind of if it looks good, right? Hopefully. That was 27. We're getting closer. Nope. Not getting closer at all, it seems. So how many are there? This was just a few. So T in it, no in it. So it's a mem. And we have another init, but we're doing a reader and it doesn't take any memory because you can see that from the call there. JSON parse, okay, we have a lot of some parsing, so we are going to change all the JSON parse with JSON parse mem, comma. Oh wait, did I just break something? Yes, I did. Because what you wanted was, damn it, was this. Okay. There's the parse string too. So the parse string should probably also use memory, right? So parse string. We have a bunch of those, and now we're going to change them to parse string mem. Okay, then we have the temp parse string. So the temp parse string is temp parse string, and those are going to be like t parse string. Okay, let's see. I just think that this bar here, the scroll bar, is still so small, which isn't great. This isn't a great feeling, right? Okay, so temp ASCII to lower, and I think it's like there's like I changed that one to lower, t copy. The t copy name is like really bad, but okay. Maybe we'll change that too. I'll change that later. So decode goes into t decode. We did that before. We have some read line. So again, now we're just swapping these. Again here, we kind of have this some preparation for using memory, but it's done the other way around. Each row, let's see here, we want a row, so it's the allocator. Okay, so that was the streamline. Right. It feels like it might get less. So encode temp. So t encode. No one is. That's not good. Like 10 code. It's t encode, but t decode. That makes sense. I guess I will have to do that. So read temp row. I don't even remember what the name is. Like it should be t read row, right? Treat road. So first new format, and we know that new format is not a thing, so it's just a mem. Okay, and then let's see here. So we have all these. Oh, there's another one, new format, and about that one is the last one in here. Okay, here's a name, right? But you want to have the allocator, and again we get to this one, and like that. And that was that one. Okay, so we have another one. Here's a new init. Here's a real one. So we want to have the memory, and then things are copied. Here's a temp init, so we don't need to even do that. And here's something, copy keys. I think that one is just keys now, right? Right, so just like keys and then the mem. Like you saw how long it used to be, right? Wait, that was a test, right? Okay. Okay, we have another one. Oh, and we don't need to do that. We can just go ahead. And here's a global bit set. So I think this works. I think it works to kind of comment out that one, but I'm not sure. So let's use T in it, which I assume exists. Here, no, you can just ignore that. Here's the temp mem concat. So now we're going to use tmem explicitly. And here we have the allocator, so it's going to do that correctly. Here's another one we're going to add, and we have the temp allocator. I think like whatever they're doing is probably okay. Okay, I would like this. Looks like we're almost done. Let's see here. Here's the concat, so we need the a like that, right? Okay, and the second one is this thing here. I use tmem like that. Now it's running the tests. Except it was crashing in JSON test. Okay, so the simple test was failing. Okay, simple test. Simple test in the JSON suite. Yeah, you don't know. That's the problem with that. So JSON, the utils, the tests. Here it is. So this one was the one that I changed. And I did it somewhere in some way that it's bad. Now, unfortunately, I have this as a copy, so the only way I can see what I actually did was doing something like this. So temp parse, right? Temp parse, this look good, I think. And then we have all these parse strings that would change into mem parse strings. Oh, it's wait. How did that work? It's freeing it. That looks really bad, right? Because it's, it's temp. So I think that maybe if I do like this, it will stop crashing. We'll see. No, it's still crashing. What the heck? Okay. Next step is actually doing this. It's okay. It's failing on simple test, right? What is that doing? So here's the simple test. Let me just take that one and make it a normal code that I run. So we're going here. We replace this. I always can call the simple test from there. Simple test. Right. So there we go. And now I just run this single thing, and now I have to make sure that it's using the new library. So yes, it's using the new standard library. Everything is okay. Let's run. Oh, Is this right? Oh, maybe I shouldn't, have Linux as the target since I'm on Mac OS. Okay, here we go. So out of bounds memory access. Okay, so we get an out of bounds access on the hash map when we're doing a get int in here. So we defer free this. And this worked before. So maybe it's doing something differently in the JSON parser. So let's see. We go into the JSON parser. Maybe I broke everything. So this is the lib. This is the normal one. Here we go. Here's the allocator. Here's the parse. In this case, we have. Oh, right. So I was just thinking about like, how does this work? And I guess it doesn't. So let's look at the history of this one. So the way things changed here. When you start using, like, if I'm just going to test something. So what happens if I, oh wait, that one's supposed to be like that. I think JSON. We have the other one, the original one in the other file. So we have two JSON. So the JSON C3 in here. So this one is like getting that mem and then using mem, right? So it's using that particular function and then use the allocator that it got from outside as the main allocator. Okay, great. That's why this, I think this might have failed too. If we go put here, we have the allocator, we assign the allocator, but this one, let me just call it mem2, right? Because then there shouldn't be any confusion with the global. And it still crashes. Okay, that's not the problem. Stack. It's called something else. But I wanted to make sure that that wasn't the problem. So something else is, of course, in this. So parse any and parse from token, and then we do everything. But there must be something in here that I'm doing completely wrong. So I'm just going to compare this this file. There should be some way to kind of I know. I can just take this thing. That was the correct one, or the work one. And then I paste that one over the new JSON. So here you can see all the diff. So we move the allocator, right? And that looks okay. Parse, we just change the order. That looks okay. Temp parse, we do use the temp tmem, which looks good, right? This so far, everything is fine. Here we have the in-stream, and then we have the allocator. That also looks fine. We do have this memory in the other place, but let's just keep that call at smem just now when we're testing this, right? And again here, this was this change here that we did, right? And oh, forget the ordering. So let me fix the ordering. So smem ordering correct. Now let's see if there's something else. So there's one more thing here. We have new with capacity, and then this one looks completely okay. And then finally this one. Again, this new way looks fine. And there's this thing here where we do the SMM, yes, but there's nothing else. I mean, this is super strange. Why does it fail? So, and it fails right here in the get int. So let's look at the object. So maybe it's object that is actually failing. So again, we have two objects, and one is in 7 and one is not. So this is all, no, objective C. This one. So this one, and then the one in the other libraries. Okay, let's look at the diff now. I guess you won't be able to see this that I'm looking at. So I'm just gonna say I have the copy keys, right? And I'm saying that the copy keys is going to be the same as keys. I have to check that. So the copy keys. So in hash map, we're gonna go to hash map. This one you can at least see. So we have copy keys. Copy keys. This is the one. So key TLS is the same as copy keys. Yeah, so T copy keys is the same as keys TLS. That means I didn't do anything weird. Okay, so now let's look at the diff here. So I was changing the copy keys for keys. Oh wait, I was changing a T, a new init with the allocator with a T in it. Wait, what? That doesn't make any sense at all. So that was probably a problem here. Everything else looks okay, but that particular thing was just making the map a temporarily allocated for some reason, and that was completely broken. So I'm assuming it end up looking good now. So keys, right? I need to revert these changes, the other changes in object. So the keys. So it's just this little T in it that sneaked itself into the source code for, I don't know how. Okay, so now that's compiling, then we can probably safely say, guess that we could run the unit tests, if I can find that. So we have these test lib 7. Questions? Oh, wait. So on a more serious, what made you decide to add fn? Oh, it's like breaking. Woohoo. Okay, I'll fix that. So yeah, if actually the function it is not that. Oh. Why? Wait, everything is broke. Okay, that was just the URL tests. So let's see what broke there. Okay, so the assert violation here, it's assuming that the string is empty. An empty URL doing string format. What is it then if it isn't that? So we can use these new test equals, right? Eq stir dot. Here's a better error probably. What does it say? Empty URL is. Okay, so empty is not equal to empty. Oh no, the struct type, sorry. Oh, we got an entire. Oh, the URL. It's no longer printable. Is that it? So let's look at what the URL used to do and what it doesn't do now. So here's the URL from net, and then we have the URL Which one is this? So this is the unit one. There's libc one. No. Okay, so we need a URL from the standard library. Should be this one. Yes, and this is the lib7 one. Okay, let's look at that. So I'm going to make a div here. Again, I'm sorry you can't see this, but okay, that's just unfortunately I have to do it like this. Okay, the code, I'm looking at where the code, that one looks okay, but something, allocator in the wrong place, allocator in the right place, the code. Oh, you see it, sorry, that was the format, right? So the format, the URL needs to have the printable, be a printable, first of all, and I don't know if it is. So URL is a printable, but it probably didn't implement the printable things. So here we go. ToString. Where is the ToString? Here's the ToString. Yeah, okay. So I found the ToString. And is there a toFormat as well? No, there's just a ToString, and the ToString is not going to cut it for printable now. So that's the problem. So let me just roll back what I have here. Yeah, so the fn is retained. It's not like strictly necessary, but it's retained because it makes toolings very simple to kind of handle these kind of when you have when you want to search for things, and it also disambiguates some things with lambdas. So lambdas are easy to kind of define inside of a function, so that's nice too. And finally, it's actually also that it makes it easier to spot where there's a symmetry between macros. Also, macros have a prefix of macro foo, and then there's like the function foo, right? So it's kind of somewhat symmetric there, symmetrical. I was thinking of having generic before, so that would be like macro blah 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 foo, function foo, and generic foo. So they all kind of started with something, but the generic was never really necessary. So it ended up being toFormat. So that's not a good reason why. But we the tooling thing, and also I actually wrote a whole thing about this. Like, you want, it's a nice thing actually to be able to spot where C3 code starts and where C code starts. It's not intended to be different, but okay, I have to probably, oh, this isn't ideal. This is never very much not ideal. Having a lot of temping codes is in here. We have to have a stack mem. Give me some, what could it be, 64 bytes? Sorry, I was concentrate, so. So anyway, it turns out that really being distinct has some advantages actually, so that you can see when you switch between convert between C and C3, it's actually easier to kind of spot which one's which one. Okay, so then we do append chars. Oh, print username. So what this does is this allocates some memory on the stack and use that as the thing to allocate from for. So because if I use the temp allocator, there are some issues that it's very subtle issues that might cause overrides. So I cannot use the temp allocator in this kind of situation. You shouldn't do that anyway. Kind of tired. Yes, I am. Is there temp encode that I'm like temp encode that I'm now overlooking that? Where does that come from even? You know, here's a temp encode. Is there no T encode? What the heck is doing that encoding? Encode? Is it somewhere else? Okay, I don't know. But there's a encode, right? So let's assume there's a temp encode. Temp encode. What the heck? Oh, here's the URL encoding. So encode length, I have to change this to, okay, so this is wrong, right? So we don't want to have encode, no, it's using this is, why does it use the, like, yes, it can do like this. Okay, that will kind of work. Why did I do like this? If I did this, yes, this will kind of work. You allocate on that one, you have the pool, that will work. Okay, but we have new encode, we should go away. I kill you. I kill you. Yes. And then we're gonna have T encode. Just let everything else. And then we're gonna have the tmem in there. And then we're going to go to code. Again, it's going to grab that temp allocator. Am I doing this in the wrong place? URL encoding. Yes, of course I did it in the wrong place. Okay. Yes, this I already did this, and then I started to play around with this, and I was like, why does this look so weird? Right. Good. Roll back. Okay, URL. Here we have it. This is the one I should have been working on. This is the toString. Yeah. Good. So, to format. Maybe if I didn't. Alright. Show history. I'm just going to grab as far as I got before I revert everything. Because that was one long function for, just printing things in a way. So grab that, and now let's edit in the right place. For Christ's sake, what am I doing? Okay, Okay, where's the, oh, there's the to format, and I didn't. Okay, almost done, almost done. Right, okay, so we are here. Get the feeling it's like getting longer every time. So here we go, do this SMM thing. And now we're done with that. We can print that one. We can append the course. We don't need that. We need password. There we go. And then we have the password. You can just do it like this directly. No need to do that separately. Same thing here. Take the username, encode it, and then we go ahead. There's a password. We don't do anything. F append. But then we do a temp encode again, which I don't want us to do. So we need to do another one. Again, some second. Now the host might be a bit longer. So let me allocate onto the 8 for that. So self host, host. We go for host, and then we want to we want to print that one, right? And there's maybe port, and then we just print f of colon D like this. Right, and that's oops. And then next up is this one, another temp encode. Stop temp encoding things. But we have to self host. This is actually getting pretty long now that it's done this way. Okay, so yes, it's the path. We're almost done, I hope. So I guess I don't want it to allocate in memory, but might have to do that. So like that, and then finally we get the query, and then we can just f print this, and then we can just print self query, because the self query is hopefully a string, right? And then finally we go for, here's another one. We gonna another temp encode. Okay, let's grab some stack memory again. And then we encode that fragment as a fragment, like that. And we should have printed this one first. So let's do that. So print that. Okay. Are we done now? So now we got to the end. So that's the entire thing. Now the problem here is we're going to return the length. And we don't have that, so and we're going to collect that all the time here. So throughout this. So we have len, and we're going to have length plus equals this one, and this might throw. So pen chars. No, it's going to be a print, right? So print. This might throw. Then we have it. You're going to print another one. Print. And if that then print. again, we keep throwing things. If it's not that, so if it's is a username, len plus equals and then throw, len plus equals and then throw. Okay, it's going to be smem, and this is kind of scary because I just mistyped smem. And then we have the length, and then we okay, length plus equals f print at smem. We're gonna leak. Go port, then plus equals, then plus equals, then here, then plus equals, and I guess we're gonna do smem. If we have a query, plus equals, then plus equals, and there's a fragment, and it's the smem, then plus equals, and then we're done. Just all of this, right? We could probably compact a bit, like this one, right? The one with the stackman, we can't do anything about that, unfortunately. Okay, so that looks about correct. Now, probably there's a bug somewhere, right? So query builder toString, yes, but we can do a string format, right? Mem, and we can do just like this. Not super nice, but it's better than the alternative. So do we have the query string somewhere? New parse query. We'll look at that later. Okay, so f append, so still print. Right. Parse query, vals to string. Right, so parsed query. And it was vals. Okay. So we have one problem here. So it's idempotence of this particular this one, the URL. So again, we're kind of we're not getting what we got, blah blah blah, and want something else, right? So what we got JDBC and user and out and PPSSS and localhost 36, Sakila. We get the struct type stuff. Okay, so let's go back to here. At some point in time, I was apparently encoding a struct anyway. So okay, so where is that? That's the query itself. Okay, query, where did you go? That's the encode. Path is fine. Here's the query, right? So it's printing the query. Apparently, so the query itself, okay, so it's what was that in? It was a toString, I think. Could it be a Venus toString? So the query is self query. It says, just self query there. What did I have in this place? Where's the query then? So it's a URL, right? So it's URL. So what's the query? Here we go. So query is a string. But what's the why? Why is it like that? So I got the wrong thing afterwards. So let's see. You have a URL to string, but the URL to string, that was that's not the query. So the URL to string. Let's see how that looks like now. To string, right? Did I kind of keep that? So wait, I did the whole thing here, right? With the whole, let's do to format and all of that. And I put it somewhere else. So here's the to format, right? A URL, I kept this URL to string apparently, which is not going to work. But never mind. Okay, so we have that one, and now it's going to say no, URL to string is not. Okay, query string format mem URL. And we want this, and so we want to see what we get if we do it like that. Parse to string. So string format mem %s parsed. Then we can of course continue, like discuss whether string format is a good way to get the to string of something. But that's for some other time. Right, let's see. We still get an error. So we still get the same problem. In here. So this is the test. Now the query is the query, right? So the queries comes from the query builder. So let me just, if I just print what that is. I think that the test runner should be, you know, giving us some information. Yeah, here we go. Okay, look at that. Look at that. It's when it's printed, it does give us the struct type. So we are already in bad territory. So it's, what are we doing with like the URL query values? That's the problem here, because we remove the to string is not used anymore. So oh wait, are we in here? Is this the right place? Because I see these and I'm getting confused. Okay, well, let's not look at that too much. Right. So we have a to string, I think, to string, which is used. Oh, there's the URL with blah, 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 which indexically coded, and the to string will assemble it. Yeah. But except we don't do that. So we have the whole, there's to format there, to format free, and there is no thing URL query is, and there is nothing for URL query. So to string, right? So that's the query values. I must have destroyed that one as well. So we have URL query values add to, and here's the URL to format. So I think I overwrote that kind of thing there. So here's the here's this one, URL values. So to format, we want this. We don't need an allocator anymore. So we shouldn't have a pool. Now I know this one has one, but that's not the thing. So let's have then. And we go through this map and it encodes the key. Yeah, it encodes the key and the value. Mem. Oh well. Oh well. Okay. Stack mem. Let's grab a bunch of memory for that and call it mem. And then encode that here. And I'll go in here and do everything in here. And we're gonna have a nested stack mem. That's gonna be okay. Now for each value, we are going to append this. If it's not the first one, print. And just print again. We do that to encoded key, which is fine. And then we print this one. And now we have to do our second stack mem. I'm just going to assume that this is going to be enough for most uses. So we are going to do another encode. So let me explain what this does, by the way. The thing with stack mem is just it allocates on memory, but would have the heap allocator as a backing allocator. So it should always work, but you never know. Maybe there is no heap allocator. Okay, and then I put this. No, that one has to be outside, so we're going there, and we have this for each value. Was that inside or with outside? It's way outside. Okay, so it's way outside. So the first one for each thing, there's this. Right. And now we have to track the length as well. I wasn't thinking about that. So we have a length there. We add that. So let's see, that's the stack mem there, and then we're outside, and we don't need to do this. We just return length. Okay, so now we're done with that. We're gonna pull this one URL up, and we're gonna do a convenience function that actually does the toString, because I think that's gonna be used. So we have a toString for this one. Fn use string toString URL takes a self and then an allocator, and then it does string format the use the allocator on that, return it. So okay, so now it should give me the right things, except I used the stack mem and stuff in the wrong way, and we put the allocator there, and I forgot to take, and it should have like the self. That's better. Then we have this, we have the mem, right? And then we have the mem again. So let's just do an smem there. Oh, and there's the, that's not the syntax. Right. Maybe we can just use mem here. It's kind of useful because it's over, it's covering bad things with the, it prevents me from using global allocator, which I shouldn't do that down there. Right. So mem would shut up a previous declaration. It would indeed. That was the intent. Okay, I guess I can do that. Yeah, now we all pass. So all of them have passed. So there's a question here. What editor? So something on a more serious news. So still browser. What code editor are you using? Yeah, it's CLion. The CLion here. No. Okay, so with that done, there's, I think like it's passing all the tests and everything. Let's just run this whole thing. Was this? Let's see. So this is the, that was the unit test that worked, and then we had the other, the tester program, which is running the test suite. I'm just going to do a send to check with that. Meanwhile, I'm going to check that I didn't change anything else. Yeah, so updated, created a unit 7 for all unit tests. And I kind of gonna commit this as push that. But this also kind of fixed some things in the standard. I also fixed these things in the standard library. So that in the new things in the standard library. Okay, I'm going to let that run, and we're going to, if you're staying with me, we're going to look at some more things. So we have this one, which is contributed here, Koi. It is using new encode and so on. So I would like to change that. So this is the only contribution so far. I would hope that people are interested in making more contribution in terms of these compressions, compression stuff. So here we go. We have a write and we do a new encode. So let's find this new encode, by the way, and we want to change that. So here's the encode. Okay, we got an encode that's calling the new encode, because presumably the new encode is the one that I wanted to use. Yes. So we're going to kill this one completely, and we're going to put the allocator first. Right, so we have the allocator, and it doesn't have any defaults, right? And now we just have that one, and it's using that for allocating everything in here, right? And then we have the new decode. Yes, so we have decode and new decode. So we're going to kill this one decode. And we're going to go for, the decode is going to start with an allocator that it takes always. The question is, do you want to have like temp decode or not? Right now, it doesn't have that. It doesn't need to, like, not everything needs to have the temp decode as the convenience. It's just the functions that are the most used, right? Let's see, I accidentally started that one, but that was not what I wanted to test. I wanted to test here. So here is it's going to, yeah, so it's going to fail immediately because it uses the new decode thing, but we're going to fix that. So we get the mem, all right, and we'll get the data. So that looks fine, and then we'll go for this one, and again we're going to change the encode. So we go for the mem encode here. We have another one which is using this like the new read. Okay, so new read is going to go away. This is just going to be read. So we're going to change the name to read. Right, then we're going to move the allocator. Oh, look, it's using the temp allocator as well. Okay, but that's fine. It's just using it in the, yeah, it's using it in the right way too. Okay, so we're gonna load the temporary, right? But we already talked about that. That's going to be a different name, but we'll get to that. So we, for now, just do the decode with the allocator being the first argument. Cater, right? So sorry about that. So let's see if that passes. No, it doesn't, because something here. New encode is still in use, right? So we shouldn't do that. We should use mem encode. Oh, I must say I really like it now. Much better than before. Okay, maybe it's... Did I not change that? Maybe I forgot to change it. So there's new encode. It's still named that way. I forgot about that. So is there anything new? No. Okay, we have somewhere, right? Somewhere over the rainbow. There's this thing here where we actually want to tmem. Right? We're going to use the temp allocator. So it's kind of obfuscate a little with this one here. But that's the one who's going to make sure that this one doesn't randomly leak, right? Here's something interesting. Here we open a file, right? And we want to do like, we want to write that, but we have another function for that. Like, do we need to know how long it is? The written thing is going to be like just as long as what we write. So there is no need for that. We can just use file save, right? File name, right? If I remember correctly, save. Yeah, it's just saving the data. It does throw something, so we can have like this. You have to have it like this, but otherwise it's just going to we just return the length. I think that's the length is kind of useless. Like, oh well, anyway. So then, right, because that's what you're gonna save. Okay, so we just have to output it here, right? Too. So okay, so that one is close. Is shorter, much shorter actually. So that one, due to this one being short and this other one being, just let's just change that one, by the way. But after fixing this, so low temp. Just going to be okay. The wrong thing again. Oh no, that was right. Okay, so so file has low temp, or should we do that later? We are here. Let's not get ahead of ourselves. Core, let me leave that one because that's so much a consumer kind of thing. So we have some things here, some Diffie-Hellman, okay, some encodings, right? So we have base 32. And look at that, we have the allocator almost in the right position, but not quite. So it's for encoding base 32. So what we're going to do is like we put it first. And then we have decode. Again, it's not the first one, so we're going to put it first. And let's see here. So we have encode new, and that one's going to go away. So we have T encode. That one is fine. In that case, it's just going to go encode, and we have the ordering wrong. So tmem. And we're going to code new. We're going to remove that. We're going to T de-encode. And again, we put the tmem here. And then some padding. So there we go. And the decode length and so on. Does anything else use an allocator? So that one does, but and those do, but nothing else. So that looks kind of okay. So I suppose like the base 64 is similar. So again, we have like the allocator. It goes first, and then we're gonna put that there instead, and the same with the decode. So let's delete that part. We're gonna have like a T encode and T decode. Delete the others. Oh, T encode temp. That was wrong. So T encode, and it's going to take these tmem and tmem and yeah, everything else. Okay, then we're gonna have CSV. I think I already did something to the CSV. That sounded weird, but I already did some coding here, trying to fix this. Right, so there's another encoding, and then there's hex. And we just have the code, and these already look okay. I think I fixed them earlier. And then we have JSON. I think we are in here and just played around. Let's see, Adler. None of those are kind of doing anything that is allocating anyway. We can go to IO later. I want to have a look at through the time, because we have this format here. Does that conform to? Yes, it does. So that one's nice. Zip is missing. Okay, atomic. Here we have the load and different things, but do we have any allocations? I don't think so. We have the bit swap, the different bit functions. Right, now we can go to threads, because threads is going to have some allocators and stuff. So we have the buffer channel. So we have the new init here and the init, right? And again, we see like we do have this, you know, the problem with having new init that we want to then change to be the normal thing. And we have the buffer channel. Do we want to have this temporary? No, it doesn't make sense to have a temporary allocator for the buffer channel, because this is going to be a long-lived thing. So you don't want to do that. That seems like a really bad idea. Let's see here. Sorry again. Somewhat. Okay, so the fixed thread pool, on the other hand, it's always doing using the heap allocator. And that might be somewhat confusing. But it has to do that. It does all sorts of other things too. So I don't know. Maybe I should just. I'll just leave it for now. There's some init there on buffer channel. Again, we have new init and we have init. So we're just going to drop the new init one. Let's go to events. So event thread, what's this? So this is something I've been working on, and I don't think that should be in even. But yeah, this one is not in either. It's like leaving something partially done. That's really bad. Unfortunately, it is there. Okay, so we have some stuff in here. I think we cleaned that up. We have the HTTP rudimentary one that I started on, but it's not done. It's probably very, very dated at this point. So, we're going to go to internet address. Hello, internet address. So, this one already has a to format, but it also has a to new string. And it does the same thing. Bye. We have the init address from string. Since it's not allocating anything, this is completely fine. So is this IPv4 one. And let's see if there's anything else that allocates. So allocate, no, there's nothing else. Wait, there is this add info, right? So it's going to go for some temp allocations, but then in the end, it just returns an AI that is something that you get from here, right? So it's an OS thing that you can't really do that much about. But there are some things here, right? So you have IPv4 to int, right? And we have this int to new IPv4, right? So this one is taking a number and creating an IPv4 string from that. And we have bprintf, right? So we have the buffer, right? And we have the allocator that we're using here, right? And then we have the temp one. So that's not very useful. I don't think you can just put tmem there. It's not going to be like this, some super used. Okay, so there is something to do there. Clearly, we are going to go here down. Let's see, new socket, which is an actually new socket, not a socket that is having the allocator. So is there anything else that is done running the allocator? Maybe URL. This was the one we were like playing around with before. We have the parse and so on. So I don't think there's much to muck around with there. Math. Again, math is usually not allocating anything, so I don't think there's much to look at there. So we go back to core basically. I think the array ones, that's are pretty much okay. We have the concat new of the arrays, and that one should go. That one should go completely, and we're just going to keep this concat version that we are. So people are probably not aware of this function. These functions actually, there are a bunch of array functions that you can use to concatenate your arrays in what's it called, when you have when you get arrays from different places and you want to just put them together. These are fine, right? Oh, sorry. So I got the slice 2D bit order. That one is not doing allocation, so that I can recall. We have the print of the backtrace anycosts, right? And none of those are really allocating any memory. That's interrupt, no conversions. They tend to do bad things, but I think these are kind of not non-allocating ones that are going to into a buffer. All of these. Okay, then we have the D-string one that we're already in there and played around with this. This is the question we mark with like new with capacity. Whether that should be a thing or not. And the new here, right? From string. I mean, that's what it is. But I'll get around to that later and I have to think about it a bit. And here we are. Oh, benchmark collection create. Who's using that? So benchmark collection create. Here it is. It's actually always using a temp allocator, tmem, right? But we just changed that one to not have a default argument. Okay, that's, and then we have runtime tests again. I think we have something like, yes, test create collection create, and again we're gonna go for that, and then when we use it again we can use tmem. Okay, so we have the strings and now we have various things. These are mostly I think fixed, but let's see if we have some. Yeah, new from UTF 32, new from B string, and so on. They all take the allocator at the beginning, so that's okay at least. New from struct, yeah. So they kind of create new things. Okay, let's just keep those for now. String to real. Yes, that's a helper thing. Tests. No, these are, you know, printing stuff and print the panic. Okay, yeah, that makes sense. So also not allocating. I think we mostly, here's the frame scheduler and that doesn't allocate, so yeah. Oh, it does allocate, but it uses the default. So okay, we have here decode mem, right? The decode temp, so that's the temp decode. Sorry. And t encode. Let's see if someone has a question. Okay, I see. Yeah, so naming is good now. Yeah, it feels much better. So we have some. Oh, here's the test, right? So concat new was the thing, right? But we're just going to change that to be like mem, and then we're going to concat. So because we have this small, very tiny mem thing, it's not a big thing to add. Before we had like allocator dot heap, and that was a different thing. Like no one wanted to write this for everything, like allocator heap, right? This is just pushing everything. It's like it just takes all the energy out of the room, all the oxygen out of the room, right? So here we need the allocator, right? We have oh, there's no new string, right? So there is no to new string. Yes, and what did we do with that? So we had the init address here, and did we do a to string for that one? Like to string, to format. This is to format for that one. And I guess we can do a to string. Yeah, we should have that. Let's have that. So string init address to string self, and then you just do this. Seems stupid. Yeah, always do this reflection though. Okay, so then you take yourself and you reflect that, And now we can have a allocator. Allocator. And then we can have a temp, even a temp string. T string. And we get tmem. Like that. What's a T? What was T string? Or what was it in Resident Evil? The T virus. Yeah, that's the name. Two new string. Two T string. That's easier. So go there. Free. Oh, here's the from string. Then it has to be taken mem, right? What? Why does it immediately free that one? Okay, well, we can do that. Two string mem. Two T string. Okay, then we'll have all of these. So this should be replaced by 2T string. Thank you. Okay. Oh, we found something else. Oh, there's a new init for buffer channel. Then we are gonna go for that, and let's have a. That was the way we initialize it. So a lot of these new inits. I wonder if you could just pass memory, not memory. I mean a bit of data to do other things. The stack memory. I guess I have to do C. Something new init. Then we change that to init mem. 11 places. Okay, I saved some work. Yes, it looks like it did indeed compile, and it passed. So I think that was like most of them. There's the D string one. Maybe we'll rename D string too. Because sometimes I really would like that one to be a din string or something longer, something slightly longer. That kind of, because it's a builder, right? So people don't use it that often. So it doesn't have to be like a very, very dynamic string. I mean, dynamic string, it doesn't that's much longer, but it will give people that's a much more compelling name. Let me show that. So the way it works is, so we have a lot of use of T string, right? We have these, okay, like for example here. So if it said dynamic string, or it could just be D string there, right? Dynamic string, right? It's din string. Actually, it's not bad. I mean, this is also var string is another one. Then you have to do v string, variable length name. You can let me know what if you like. If you prefer D string, din string, or var string, those are the options. But that's something we might change later. It's not as much of a problem as the init, the new thing has been.
It's been bugging me for a long time. Um, but it's not easy to kind of come to these kind of decide. Did you know, by the way, that you can just take like take an arena you can just do allocator wrap around some bikes and you have an arena allocator. Did you know that? Um, so it's like super easy to kind of get. If you know like the bounce or something, you can always just do that and pass in a dynamic allocator. An arena allocator that's just based on your buffer. Um, and yes, people were asking, I think, about like why is there like a simple heap allocator like this? The reason for that is that when you do some allocate, sometimes you don't have a heap allocator. Basically, that's it. Um, you have a chunk of memory, like an arena or something, but you want to use that data as a heap allocator. So then you end up with something like simple heap allocator. So this one is not like a great performance kind of thing. Yes, tries to do the trick. And this one is used for WASM because WASM doesn't have a heap allocator, which means that you either, you just can just, it's just linear memory, just work, but that works poorly with everything else. Okay, let's see. We have tracking allocator or tracking allocator. That's one is fine. Maybe we should do some. Um, let's try to do this anyway. Uh, I failed before, so replacing files. We're gonna do that, and we're going to make it start like that. So I hope I don't regret this. Oh, it's just like 68 occurrences. That seems weird. What happens if I do it again? Like, okay. Maybe it's like there are more, and I don't get everything if I just do that. Okay, so replacing files. Now I want the other side like this, and open find window, and replace all. Alright, did I actually get all of them? Replacing files. No, look at that. There's still some of those for some strange reason. Like, how many times can I do this and I get new matches? Okay, apparently not anymore. So now let's see if this actually compiles, and yes, it does. And we updated the whole thing with more. Let's see that I did actually update the right one. Yes, I did. So we are completely in the new generics here. So that's interesting, scary, but we kind of getting invested in this syntax. But I mean, you could still go with that syntax. I don't think it's super bad. It's just that this is easier to kind of easier on the eyes. Feels like less of. I mean, like this, it looks really good. But then when you do some things, like if you declare it somewhere, like let me give you an example. If I declare something, this is fine. But when I use it as like inside of something it's I mean like this, like list x is list. No, this isn't very nice to kind of work with. I think we can get that and you can get that and um, we can do the cost, right? So it's this thing again. That's okay. So it's you can get the space in. It's kind of iffy, but yeah. Next thing really should be to fix this path, and I think the thing you want is like you basically the things that the what I've used would be it's path from Python that I remember, and then I guess um, from uh, Objective C, we had the it has the URL, and it's URL that does, but also Objective C for a long time just had this. Yeah, you have a string and you can append the next path and kind of use the string as a path, which is super convenient because you end up there are so many times when you kind of have a string and that's the path. So the fact that you can't convert a string into a path is kind of problematic. So there are two ways to kind of go about this. One would be to say like a path is a string, right? So it is a distinct string with some extra stuff on it. Or you could even say like, yeah, so a path is just an alias for a string, right? And doesn't have, there is nothing more than that. So what path does give you is that you never, once you have a path, you don't need to normalize it. And by normalizing it, I mean taking, oh, you can look at the normalize function, by the way. So normalize is like this long thing that you have to do, because we can have stuff like slash dot dot slash dot dot and so on. You want to do normalization because it's just a mess sometimes, right? So you want to contract things and so on. If you have a path that is already okay, that's not a problem. But as soon as you start to you want to do something, you kind of want to do the normalization. So how do you avoid doing that necessarily? And that the idea was to have like a path that was always, pristine. It was it was a working path, and then everything, you don't need to do any checks and so on. There is no chance of anything going wrong. But that's a very old time thinking. I have to admit that. So it's not very friendly for anything else. Like these functions are fine, get the extension, get the absolute, and so on. But the usage is not. So you kind of want these functions, but on string, to be honest. The problem is now you have to, you have to do it differently depending on what kind of path environment you're in. But that is something you could make the user have to worry about if they want to convert things. So we could also add a localized path that you could do could know that stuff like that. I mean, look at this. This is just like embarrassing. So it tries to delete the directory in which month. So the path to delete, right? But look, it's like it takes the path. In this case, it actually uses the path. The other one didn't. So there was some where you kind of took the string and then you use that. But anyway, so I think the path should kind of go. it should be, but there are like 1,000 tests on this, but I think it should probably go. There are also uses like you want to have like a v-string path and so on, so that's very useful. That's very important. Sorry, not very useful. Well, it's useful, and but it's important. And you're going to get like the start of base name, and you want to have like the various things. Like the base name is very important, the directory name, and so on. So all of these are very, very nice when you work with things, like to get the volume, parent, and so on. And normalize. I mean, you see the code where this does, like all this is something you have to do otherwise. Oh, anyway, so let me look at if someone has any other problems. So the naming is good. Yeah, that was the last one. I think we're kind of done here. Let's just let's hope that this kind of fixes things. So what did we do? We change to generics in lib7. What else did we do? We did we updated koi. We updated what else? Some other place like base and other encodings. And yeah, I guess that was it. And multiple other small changes. That was very vague. Okay, so push this. And now I can just look at the I just have to make sure that it works later on here with the actions. But yeah. Okay, let me look at this. So I have a report here that compiler build is failing on Mac Silicon. I think that was like the next thing. So I have no idea. They are using so many weird things here to get the Docker build with Docker. And wait, why are they using? Oh, so it's like what? They're running a Ubuntu. No. Build. I have no idea what this is. Okay. I'm just looking at one error report. Okay, so I pushed that part. There were some failures before, there were also these very long running tests. Let's see. Oh, that one has been running for 2 hours. What's wrong? So maybe something crashed. So maybe there's something wrong with the latest, because the MSVC debug did not continue past, like it succeeded with part of it, but the compiler tests, like it was stuck at attributes repeat param. Sometimes it's just crazy where it kind of gets stuck, but sometimes that's the real problem. So this also looks like it's stuck at 107. Oh yeah, it's kind of hard to say. Sometimes the debug version of MSVC yes takes too long, and it just fails for no particular reason. But this case, it might be a problem. So we'll see. We'll see. Everything else is passing, though. Okay, so thank you for sitting here and watching, and have a good night. Goodbye.